Welcome to the Lean Six Sigma Academy Yellow Belt Training.
Welcome to the introductory module of the Lean Six Sigma Academy Yellow Belt Training Program. This comprehensive training will follow the LSSA skill sets, which can be downloaded from the website lssa.eu. In this module, we will discuss the first learning element, called world-class performance. This module consists of 5 performance criteria, the history of continuous improvement in general, the value and foundations of Lean Six Sigma, and an overview of the types of businesses that are deploying Lean and Six Sigma. We will also discuss briefly 2 other process improvement methods, the theory of constraints and total productive maintenance. In order to stay competitive, all companies and organizations need to have a constant focus on reducing costs. There are 2 types of costs. The first costs are the ones that are obvious and clearly visible. Examples of this type are bad or defective products and customer rejects. Activities that do not add any value to the product, like rework and waiting, are called costs of poor quality. Examples of less visible costs are too much paperwork, unused capacity, and excessive inventory. These types of costs are called hidden costs. Every organization has both types of costs. In general, an average company has around 15 to 25% of its turnover as cost of poor quality. This sounds very high, but is a realistic number. Applying Lean and Six Sigma helps companies reduce cost of poor quality. I would like to start this training session by explaining quality management in general. You might be familiar with quality control, also called total quality management, or TQM. Its main focus is to prevent bad products from being shipped to the customer. Of course, most companies have this focus, even if they don't call it TQM. More and more companies are currently making a transition to quality improvement, sometimes using the Six Sigma DMAIC roadmap. However, even using Six Sigma DMAIC, one is solving problems after they occur. The expectation is therefore that in the coming decade, more and more companies will start to make a transition to quality planning, using design for Six Sigma techniques to prevent problems from happening in the first place. Companies aim to produce at the level of operational excellence. This means that they have a constant focus on 3 elements: time, cost, and quality. Their focus is to deliver high-quality products or services, deliver products on time, and produce products in a cost-efficient way. Operational excellence is about producing cost-efficient products without failures that meet customer expectations. Very few companies reach the level of world-class performance, meaning that within a certain sector, they are the best in class. Besides producing at operational excellence, it also means that these companies develop new products that exceed customer expectation. For technical products, it also means that the fallout rate over time is known by applying reliability engineering. Good examples are companies like EasyJet, Apple, and Dell. Lean and Six Sigma are not completely new. A lot of their methods and tools originated over the course of the last 100 years. Some will say it all started with Ford, about a century ago. Henry Ford was the first person to truly integrate an entire production process by lining up fabrication steps in process sequence and by using standardized work and interchangeable parts, which he called flow production in 1913. The problem with Ford's system was its inability to provide variety. The Model T was limited to only 1 color and 1 specification. The result was that all Model T frameworks were essentially identical. Besides Ford, you might be familiar with a few other names, like Deming, Uran, or Ishikawa. Take a minute and count the number of names you know. I will not go through all the names here, but for Lean Six Sigma, it is important that you know at least the names Ono and Shengu, who are the founders of the Toyota production system, and Smith and Harry, who founded Six Sigma when they worked for Motorola. You can download an article that describes the history of Lean and Six Sigma in more detail from the LSSA website. This is an important slide for companies that want to know where to start. Basically, you cannot start at a higher level unless you have implemented the preceding phases. Phase 1 is about creating an overview and standardization. The main methods here are 5S housekeeping and improvement activities on the work floor. Phase 2 is about stability, waste elimination, and focuses on the bottleneck within an organization. Lean tools like visual management and value stream mapping are the most important tools here. Phase 3 is about reducing variability and capability. Only after achieving a stable process, which is the goal of Phase 2, can one apply Six Sigma statistical tools. Phase 4 is about applying Six Sigma tools in the product development phase. It is about designing products that will have a flawless launch into production. As you advance through to higher phases, the tools to apply also become more and more sophisticated. Finally, be sure not to forget to look for the so-called low-hanging fruit. Sometimes you have apples lying on the ground for which you do not need any tools at all. Let's focus a little more in detail on the most applied methods, starting with lean manufacturing, also called lean management. Lean management is about the organization of the work, which focuses on an elimination of waste. There are 8 types of waste, which we will discuss later. The goal is to reduce lead time, stock, and activities that do not add value to the product. Lean also focuses on quality, but its tools are not as sophisticated as Six Sigma tools. Although the word lean was first used by the writers Womack and Jones in the 1980s, the concept originated with Toyota. Toyota is the #1 example of lean production. Another commonly used method is TPM, which stands for Total Productive Maintenance. This method focuses on all equipment-related issues, such as unscheduled line stops, bad quality caused by equipment, and long changeovers. The efficiency of a line is measured as a percentage. A metric that is often used is the OEE percentage, which stands for Overall Equipment Effectiveness. TPM is mostly used in companies which utilize continuous production lines, like metal shops, food, and automotive companies. Within companies that apply TPM, you can often find a house with the following 8 TPM pillars: focused improvement, autonomous maintenance, effective maintenance, training and education, early equipment management, quality maintenance, TPM in administration and safety, and health and environment. The next method is TOC, which stands for Theory of Constraint. The basic principle of TOC is that every production line or organization has a bottleneck. Even if the other operations are running very fast, this bottleneck defines the output of a production line. Take a look at this picture and tell me how many products this line can produce at the most. The answer is 450 parts per hour. The bottleneck should always get the most care and attention. The most famous book on this topic is called The Goal, written by E. Goldratt. The main focus of Six Sigma is on reducing variability. The goal is to improve quality to an outstandingly high level by applying so-called breakthrough projects. For this, sophisticated tools are used, like measurement system analysis, capability analysis, and design of experiments. Six Sigma heavily depends on the use of data and statistics to analyze this data. Six Sigma also consolidates many known tools with a very structured project management roadmap. This roadmap is called the DMAIC roadmap, which stands for Define, Measure, Analyze, Improve, and Control. It originated in 1986 at Motorola. Nowadays, many companies in the automotive industry apply Six Sigma. As stated earlier, the basis of Six Sigma is to reduce variability. But why is this important? Assume you produce shafts that need to meet a certain length specification. The lower specification is called LSL, which stands for Lower Specification Limit. The upper specification limit is called USL. Like any process, your machining process has a certain amount of variation. You take a certain number, let's say 20 shafts, out of your production line and measure all lengths. From these numbers, you can draw a normal distribution plot. This plot shows you the probability a shaft has for a certain length. Even if all 20 shafts are within both specification limits, the probability plot might tell you that there is a chance of producing shafts outside these specification limits. Six Sigma focuses on reducing this variability. Applying the DMAIC roadmap and tools will help to identify the causes of variation and can help in its reduction. The result is a process with a normal distribution plot that is smaller. The probability of producing products outside the specification limits, therefore, is lower. Most automotive companies and their suppliers are currently applying Lean and Six Sigma, and more additional companies and organizations are adopting these methods. They start with the application of Lean manufacturing principles, which are easily translated into service processes. Industry, electronics, and transactional companies, like banks, are applying Six Sigma tools as well. Because the methods have proven their effectiveness, the expectation is that more and more organizations will adopt Lean and Six Sigma principles and tools in the coming years. We have now come to an end of this training session. You should now be familiar with the history of process improvement and the basics of the Lean and Six Sigma philosophies. In the coming modules, we will take a more detailed look at these principles and tools. We thank you for joining us, and we hope to see you back soon at the Lean Six Sigma Academy.